This lesson, solving quadratic equations, so this is the first lesson in our quadratics unit. This unit is really going to be a lot of review of grade 10. You might see a few little new concepts thrown in, but it's an important topic, so it's good to go over some of the concepts that you may have seen before. So an equation that can be expressed in the form ax squared plus bx plus c equals 0, that is called a quadratic equation. That is actually in standard form. And what's good about standard form is that it's set up for us so that we're able to factor. So we've already reviewed factoring, but we're going to see a little bit more. And we're going to solve a quadratic equation by factoring. So solving an equation, we've seen simple equations like this where we move the 4 to the other side or subtract 4 from both sides. And then 2x would equal 6. Like this doesn't scare you, I don't think. So x equals 3. We just solved that equation. If we're going to solve a quadratic, it's a little different because some of our equations look a little more complicated, like we have an a squared here or an m squared. That's a little bit more difficult in order to solve for the variable. When we solve quadratic equations, we always get two solutions. So sometimes teachers call those roots, sometimes teachers call those zeros. But we're going to get two solutions. Be careful when you get your answer. Many times one of the answers will not fit the question being asked, and then it's called the extraneous root. If we're going to solve equations that are actually applied to a real-life problem, we might get two answers like -2 and +5 for time. Perhaps the -2 cannot be used because you can't have -2 seconds, for example. So sometimes we're going to choose one answer, especially when we get to word problems. So this is a review for a lot of you, but I still think this is super important. Sometimes we'll solve by factoring. So all I'm asking here is that you solve for a. So isolate the a. Sometimes you don't have a trinomial like the one over here in part B. What we can actually do there is just kind of think of steps that you already know, how we could maybe isolate the a. So I have a squared 49. So in order to isolate the a, I would have to take the square root of both sides. So that would give me positive or -7. Remember that -7 times -7 also gives you 49. The next one is a simple trinomial, so hopefully you remember we're looking at what multiplies to give us -15 and adds to give us -2. When I do this, I would just factor into two sets of brackets. It could be x, it could be anything, any variable. I think this would be 5 times 3 is 15. So I know that -5 plus 3 is -2, and -5 times 3 is -15. What I'm going to do though to solve for m, so this doesn't look like what we had here. Here we only had one root, or one answer, one solution. Here we're actually going to have two. So all I want you to do after you factor is split these up into two sort of mini equations, is what I call them. If m minus 5 times m plus 3 equals 0, then one or the other of them equals 0. So I'm going to split this up into a little equation and set each factor equal to 0. When I do that, I can just move the 5 to the other side or add 5 to both sides, and I'm actually getting two answers for m. And so I've solved the quadratic equation, which actually gives you two solutions. So just a little bit more about what is going on here. Normally we would use x's and y's. What I want you to know is that a quadratic equation looks like a parabola on a graph. So this is what we're doing. When we factor, like you might wonder, why did I ever learn how to factor? This parabola, for example, opens up and it has two intercepts, two x-intercepts at 5 and -3. That's what we actually found. These are the roots, and sometimes teachers call them the zeros because this is where y would equal 0. You could imagine, I'm not exactly sure how this looks, but this is where your parabola would cross the x-axis. We found the roots of the equation. When you find these two answers, you have actually found the x-intercepts of the parabola. Factoring is the concept that you've already learned before, but what we're actually doing now is taking it just one little step further and stating what our intercepts would be. So some of your equations can get more difficult if I see this. So we're just assuming that you have all the skills, you understand first, outside, inside, last. The distributive property, none of this should worry you. And then it just becomes a situation where you just have to collect like terms. I would probably collect all my like terms on each side first. And then I would probably want to always get all of my terms on one side so it equals 0. One other thing that you might have wondered is that usually when we see a quadratic equation, it equals y. So what we've done though, if y equals 0, that's how we know that we're actually finding an intercept, because we're going along the x-axis. This is where y equals 0, and this is where y equals 0. So usually what you're going to see with questions that ask you to solve, if there already isn't a 0 instead of y, we're going to replace it. We're going to say something like let y equal 0. That is how we find an x-intercept. So with this one, if I collect all of my terms on one side, remember to change the operation when you move terms from one side to the other. And then I collect all my like terms, and my equation equals 0. So I have a quadratic, and I'm asked to solve it. So what this looks like is, this is a complex trinomial. We have a value, a coefficient in front of the x squared other than 1. So we can't just say what multiplies to give us negative 12 and adds to give us 1. This is a complex trinomial. Maybe I'll show both ways. So my preference is trial and error because it's faster. So I'm going to have to think of, okay, what gives me 20 in the front? So what would multiply to give me 20x squared? I might try 4x times 5x. And then in the back, what would multiply to give me negative 12? 3 times 4 is 12. 2 times 6, I'm not sure which one it would be. Then I want to check, okay, can I somehow get positive 1? This would give me 16. This would give me 15. So if I had 16 take away 15, I would get the positive 1. So that would be my answer. If I did decomposition, to me this is a little bit more difficult. I have to think about numbers that multiply to give me the product of the first term and the last term. So what multiplies to give me negative 240 and adds to give me 1. And you might not know numbers that multiply to give you 240 right away. So you just start dividing by, you divide by 12, you divide by, I don't know. So if I divide by 16, 240 divided by 16 is 15. So remember that those are not the numbers that go in the brackets, but those 16 and 15 would be the numbers. If we're doing decomposition, we do 16 minus 15x. We break up or decompose, we split up this term in the middle into our two special numbers. 16 times 15 is 240, and 16 minus 15 is 1. So that's how we know we have the right numbers. We take the common factor by grouping, so we just take a common factor of the first two terms, which would be 4x, and we're left with 5x plus 4. And then the second two terms I can divide by negative 3, and I'd be left with 5x plus 4. As soon as I see that my brackets matched, I know that I've done it correctly. So I take a common factor, I factor out the 5x plus 4, and then whatever's left, 4x minus 3, it goes in the other bracket. So that was a lot more work. We did arrive at the same answer, even if our brackets are reversed there. but we ended up with the same thing. What we would do now, though, since we're not just factoring, we're solving for x, we split these up into two mini equations. So we take one factor and set it equal to 0. We take the other factor and set it equal to 0. But to me, this is sort of the easy part. This is like a little equation that you've seen before. Move the 3 over to the other side. Divide by both sides by 4. So one x-intercept would be 3/4. The other one, you could probably do this in less steps, but I would move my 4 to the other side, divide both sides by 5, so x equals -4/5. And we found our two x-intercepts. We solved for x. So in real-life applications, you will find very few quadratic equations that can be factored. Okay, so we have practiced factoring, but sometimes if you have really specific decimals in your question, or you have numbers that you just can't figure out how to factor them, it could be that either there are no x-intercepts. So remember, you guys, we don't have to have x-intercepts. Our parabola could be up here. So maybe you can't factor something because there aren't any x-intercepts. But then what we normally do is, if you can't factor something, we would go ahead and use the quadratic formula. This will give you the decimals that you might be looking for in your question. Also, the quadratic formula works regardless. So if there's even a question that you could factor, but you just can't find the right numbers, you can always fall back on the quadratic formula. So what the quadratic formula is, we have A's and B's and C's, and maybe you saw this in grade 10. This is a grade 10 topic. We have standard form, which is ax squared plus bx plus c. So this is standard form of a quadratic. The a is the coefficient beside the x squared, the b is the coefficient beside the x, and the c is the constant term. So all we need to do to use the quadratic formula to find our x-intercepts, again, is just sub these values into our formula. And some students will say, why is there a plus minus in here? So what this equation is, it's just this equation, but we solve for x. So it's just rewritten in a different way. The plus minus sign, that's how we're going to end up getting two different answers, or two different x-intercepts when we're done. So if we have a -10 and we sub it in for -b, it would look like -10, which would end up in this case just being 10, plus or minus the square root of b is -10 squared, minus 4 times the a, which is 3, times the c, which is 3. You don't bring any variables in, you just replace with numbers, times 2a, a is 3. So then we simplify. Usually a square root sign is like a bracket. We're going to do everything we can to simplify underneath the bracket. 4 times 3 is 12, times another 3 is 36, divided by 6. Notice the whole numerator should be done and then divide by 6. So there is a fraction here for the entire numerator. 10 plus or minus the square root, 100 minus 36 is 64 over 6. So sometimes I'll go this far, especially in this case. I can actually find the square root of 64, which is just 8 divided by 6. So now I'm going to end up with two different answers for x. One of them, I'm going to use 10 plus 8 over 6. And the other one, I'm going to use 10 minus 8 over 6. So I split it up at the end. I use the plus sign for one answer and the minus sign for the other. So 18 divided by 6 is 3. And 10 minus 8 is 2 over 6, so that would be 1/3. Part B will do the same thing, but it might have a slightly different ending. There's my A, my B is -6, and my C is 5. One of the biggest mistakes students make, this negative times this negative, negative 4 times 3 times negative 5 becomes a positive 60. It's not always that you have a minus sign between these two numbers. Two negatives will make a positive in this case. So one thing I'm going to mention at this point, usually in grade 10 I don't go into this, but you could find the square root of 96, which is going to be a decimal, and you can round it off, and that is not an exact answer. So sometimes in grade 11 math, because we've studied radicals, we could provide an exact answer, which a lot of students, maybe if you didn't have a calculator and you don't want to use decimals, we would write this down as an exact answer. So 96 is 16 times 6. And I do know the square root of 16, which is 4 root 6 over 6. So sometimes it's appropriate just to give an exact answer. Like in this case, I would prefer an exact answer. If you were doing a word problem and you actually needed to know what that value is as a decimal, then sometimes it's appropriate to have a decimal. We're going to do the same thing though. We're going to have two different x-intercepts when we're done. One is going to be 6 plus 4 root 6 over 6. And the other one is going to be 6 minus 4 root 6 over 6. What else can we do there? We could simplify our fraction. So I know that 6 divided by 6 is 1, and 4 divided by 6 is 2/3. Again, I'm not going to be super picky on this, but it is a common thing to have an exact answer here. This would be 1 minus 2 over 3 root 6. In simplest form, if we were trying to provide an exact answer. Okay, one more that we're going to talk about. If I sometimes try and factor, it's not going to work out and I'm not going to be able to find the right numbers, so I'm going to go and use the quadratic formula, but something interesting could happen here. So notice that is a -1, so negative 1 would just be 1. And if I simplify, I get 1 minus 4 times 2 is 8 times 3 is 24 over 4. And I'm going to get stuck here because the square root of -23, if you type that into your calculator, you're going to see that it gives you an error. So this is the case where we're not going to go into huge detail. You'll probably go into more detail in your grade 12 advanced functions course. But this is an odd thing. So I don't have any x-intercepts. This is the case where if I type this equation into Desmos or something, I'm not sure how this one looks, but I bet there are no x-intercepts. There are none. We can't find the square root of a negative number. So normally in grade 10 math, I would just stop there. For you guys, we're just going to do a little bit of an introduction here to imaginary numbers, but don't panic. It's not going to be, we're not going to go that much in depth here, but we could have an imaginary or a complex root. So since the square root of a negative number is not defined as a real number, the equation has no real roots. But that doesn't mean there is no solution. So a concept that is just being introduced here in the smallest way, the symbol I is for an imaginary number. So this was developed such that I squared equals -1. So therefore, this is what we would do when we run into this issue. I have my answer exactly like what you see here, but I'm going to take out the negative because -1 is the same thing as I squared. So I'm going to remove the negative and I'm going to insert an I squared instead. If I take the square root of I squared, it's just I, so I can move it outside the square root sign. And then I have these two answers. So you're still going to go ahead and give an answer. We're going to have 1/4 plus or minus root 23 over 4i. And you could have left this just as one fraction as well, but we're going to say the two roots are imaginary. We have two imaginary distinct roots. So they aren't real roots in the real number system. These are complex or imaginary roots. The two roots are called conjugates since they differ only in the sign of the term containing I. If this was me and I had to finish this question, I probably would have said x equals 1 plus root 23i over 4, and x equals 1 minus root 23i over 4. And this is just sort of stating the fact that we don't have real roots, but we do have two imaginary roots.